Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And as always, take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called the Onion Sudoku by Jonesy, and here are the rules. Hello, bonjour. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9, such that there are no repeats in any row, column, or designated 9-cell region. Digits also do not repeat within a cage, and each cage sums to the same total n. Interesting. The digit in the gray square is even. Okay, so all the cages sum to the same sum. So whether there are 3 cells or 2 cells in the cage, they must sum up to the same sum, and there are no repeats within a cage. This gray square here is even. Consider the grid as concentric layers centered on row 5, column 5, which is the middle cell. We have layer 1, which is row 5, column 5. We have layer 2, which is the remaining cells of box 5. So that's layer 2. Layer 3 is the ring of cells surrounding box 5, which is otherwise known as Fistimathel's ring. Layer 4 is the next outer ring, which would be here, and the outermost ring of the grid is layer 5. Okay, so that's why this is the onion Sudoku, because we have layers surrounding layers around in the grid. And in each layer, all caged cells have the same parity. Either they are all odd or they are all even. And have fun. We will try. That is interesting. Those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm gonna get started. Let's go. Okay, so this has, well, there's no cage cells there. These have the same parity. So we'll mark those as, I don't know, green. Then Fistimathel's ring has the same parity. We'll mark those as pink. The next layer out has the same parity. We'll make those as orange, and then the last ones have the same parity. We'll mark those as yellow. Interesting. So these, well, we don't know. So pink 3 times. Do we have any 2-digit cells which are not between 2 layers? And the answer is no. We do have pink and yellow. Okay, interesting. Orange and yellow have to be the opposite parity of pink. Because we already have 4 unique digits, 4 pink digits. Oh, that's not true. That is not true. Pink and orange have to be opposite parities. But pink and yellow could be the same parity. Interesting. As long as... Okay, so what happens if pink is even? If pink is even, orange and yellow have to be the same, have to be non-even, so they must be odd. But then we have 3 pinks adding up to an even sum. But the 3 yellows must add up to the same sum, and they're all odd. So pink cannot be even. Pink has to be odd. So since pink is odd, they must be paired with the even digits to add up to an... Because 3 odd digits add up to an odd sum. They must be paired with even digits to add up to an odd sum here. So this is odd. You're guaranteed orange. 2 oranges will add up to... well, you know orange cannot be odd, because then we'd have 6 odds in row 7 and row 3. So therefore, orange must be blue. And since we have yellow also having to be odds, because we have 3 odds here trying to add up to an odd sum. So the sum is guaranteed to have 2, 4, 6, or 8 adding up with another digit to add up to the sum, and 8 adding up to another digit adding up to the sum. So that means the maximum sum we can have is 2 and 9, which is... So the remaining digits in box 5 have to be all odd, because we have 4 even digits. We have 5 odd digits in row 7, so the rest are even. We have 5 odd digits in row 3, so the rest are even. Do we have anything else? This gray square is even, so that's even. That gives us 4 evens in box 3, so the rest are odd. So, oh, that's interesting. The sum, okay, so the sum for these 2 cell digits is at maximum 2 plus 9, because we are guaranteed 2 and some other digit must add up to the sum, and 9 is the most, so that would be 11 as the maximum sum. The minimum is 8 plus another digit, which would be 1. So that would be 8 plus 1, which is guaranteed to be 9 at minimum. So the sum must either be 9 or it has to be 11. And if it's 9, this would have to be 1, 3, 5. And this would be 2 and 4 with 7 at minimum, which doesn't work. So it cannot be 9. It must be 11 that these things sum to. To add up to 11 with 3 unique digits, it has to be 1, 3, and 7. So these are all 1, 3, 7. That forces this to be 5 or 9. 9 with 2 even digits is never going to add up to 11. So this must be 5. So we have 5 here. This is 1, 3, 7 here. And the digits here to add up to 11 is 2 and 4. So this is, again, 1, 3, 7 here. One of these has to be a 9. So this has to be 6 or 8 here, and the remaining digits in box 7 are 6, 8, and 9. This is either 1, 3, 7, or 9 here. So we cannot have a 6. So to add up, so 1 can never add up with another single digit to add up to 11. So we're guaranteed a 1 here, which means this can't be 1 there. We have 5 odd digits in column 7, which means the rest are even. Okay. Um, 3 and 8 add up to 11. 7 and 4 add up to 11, and 9 and 2 add up to 11. None of these can be 1. This is 1, 3, and 7 here. This we don't know as much. If this is 2, this could be 2, 4, and 5. 2, 6, and 3, or 2, 8 potentially, and 1. That could be a wide variety. These digits must be 2, 4, 6, and 8, which leaves the remaining digits with them are 3, 5, 7, and 9. 5 can't be here because of 5 in the column. So this can't be 6 here. So 6 has to be one of these two, which means 5 has to be correspondingly there, which means this cannot be 5 here. So this is 1 or 3. We have a 1, 3, 7 triplet in row 3, which eliminates 1, 3, and 7 in the rest of the row. So no 3, 7 here. This is 5, 9, 5, 9. 5 and 9 can only... This is guaranteed to have a 7 here, so this cannot be 7 there. 5 and 9 add up with 6 and 2 to add up to 11. We have a 1, 3, 7 triplet also in column 7, which eliminates 1, 3, and 7 in the rest of the column. So it's just 5, 9, and 5, 9 here. Again, this forces this to be a 2, 6 pair to add up to 11 with 5 and 9. So that eliminates 2 and 6 in the rest of the box. So this is a 4, 8 pair. This can no longer be 9. This can no longer be 9. So now we have a 1, 3, 7 triplet in row 7, which eliminates 1, 3, 7 in the rest of the row. So this can't be 3 or 7. It's 9 and 2 adding up to 11. 2 eliminates 2 here, so that's 4 and 2 there. That leaves this as 6 or 8. 2 cannot be here, so this cannot be 9 here to add up to 11. So we have 4, 6, 8 here with 3, 5, and 7 there. 2 is here, so this cannot be 2 there. Okay. This digit can't be 2, so we have 4, 6, or 8 there. 2, 4, 6, 8 with 3, 5, 7, 9 there. 9 cannot be any of these digits here. It cannot be here to add up to 11. So where is 9 in box 3? It must be one of these two digits, which means this cannot be 9 here. So this can't be 2. Okay. What else do we have? The remaining digits in column 3 are 4, 6, 8, and 9. Okay. This can't be 9 because of 9 in the row being here. So this must be an even digit. Okay. We have a 4, 6, 8 triplet in column 4, which limits 4, 6, 8 in the rest of the column. So we're guaranteed a 2 here. But we don't. The other one is an odd digit too. So this is a blue-red pair. We are guaranteed 1 blue and 1 red here, so this is a blue-red pair here. So as is this one, a blue-red pair. This is a blue-red pair also. Okay. This also has to be a blue-red pair because we have 2 blues and 3 reds already, and this is a blue-red pair here. Okay, that's not too helpful, unfortunately. Hmm. Okay. Hmm. 2 cannot be any of these digits here, so we're guaranteed a 2 here. Hmm. Oh, where is 6 in column 4? It has to be one of these 2 digits here. So this is guaranteed to have a 6. Does that help us any? Not particularly. This can't be 2, though, so it's 4, 6, or 8. This could be a wide variety of things. This digit, interesting, cannot be the same as that digit because they add up with different numbers to add up to 11. So it has to be the same as that digit. Okay, that's not helpful. This is A and that's A. This is B. That's not very helpful. A cannot be here. A cannot be here. That doesn't really help. Is again our 4, 6, and 8. This could be anything. This could be anything. Any even digit. These are different digits. Oh, that's interesting. Huh. So we'll make this Z and Y. Z cannot be here, so Z has to, this can't be 1. So this has to be Z here. Y can't be either of these, so Y has to be here, which means this is 3 and 7, and there are different 3s and 7s, and there are Z and Y. So that means this cannot be 3 here. It's 1. That means this can't be 1 here, so we need a 1 here in this cage to add up to 11. This can't be 1, so 1 has to be there. That's pretty cool, actually. So this must be Z. This must be Y. Y and Z see this cell also in box 8. So this cannot be 3 or 7. It's 5. Very cool. So this 5 and 6 adding up to 11, which makes this 8, which makes that 6. 8 eliminates 8 here. So this is 4. So all the Z's are 7. And all the Y's are 3. 3 must be with 8, so this is 8 here. This can't be 6. No 6 here. No 8 here because of 8 in the row. 7 can't be here. 7. Okay, so 7 cannot be here. So no 7 and 4. Okay. Hmm. Remaining digits of Let's do box 5. We have 1, 3, 5, 7, 9. No 1 here, here, or here. No 3 here, or here. No 7 here, here, or here. No 5 here, or here. These are different 5 and 9s, so this cannot be 5 and 9 here. This camp 3 eliminates 3 here, so that's 1, which makes this 9, which makes that 3. So then this becomes a 5-7 pair here, which eliminates 5 and 7 in the rest of the column. So this can't be 5. That was really cool too. This is 3 and 8 then. This cannot be 8. This cannot be 8 here. So this is 1, 2, and 8, or 1, 4, and 6 adding up to 11. That's fine. Remaining digits here cannot be 6 and 8. So we have 9 with 2 or 4 remaining, and this can't be 2 because of 2 in the row. These digits have to be 7 with 2, 4 remaining, and 2 can't be there either. Okay, remaining digits of column 4 are 1 and 2. Interesting. Remaining digits of box 2, we have 4, 5, 6, and 9. 9 cannot be here because of 9 being in one of these cells here. Hmm. 9 eliminates 9 here, so this is even. Interesting. What else do we have? It's a wide variety of things. Okay. We still gotta figure things out. Okay, where is 3 in row 2? 3 cannot be here because of 3's in the boxes, and these are both even. So 3 has to be there. That leaves this as a 5, 7, 9 triplet, which eliminates 5, 7, 9 in the rest of the row. So this can't be 5, which means it's not red, it's blue. So we have a 4, 6 pair now in box 2, which eliminates 4 and 6 in the rest of the box. This can't be blue, it's red. Okay. We need 1s now. 8 eliminates 8 as a possibility here. Okay. This can't be 6 because of 6 in the row. We have a 4, 8, 9 triplet now in row 8, which eliminates 4, 8, and 9 in the rest of the row. So this can't be 4, it's 7, which is not blue, that's red, which leaves this as a blue here because we have 5 reds in column 5. That means, and this 7 eliminates 7 here. So the remaining digits in row 8 are 1, 3, and 5. This can't be 3 because of 3 in the column, and these are both odd. So this must be an even odd pair here. Okay. Oh, this cannot be 146 because this is if this was 146, that would eliminate all possibilities for this cell. So this must be 1, 2, and 8 to add up to 11. So this is 2, that's 8. 2 eliminates 2 here, so that's 1, that's 2. That means this is not blue, this is not red. Where is 2 in row 3? Cannot be here because of 2 in the box. Can't be here because of 2 in the box. This is the only even digit left, so A has to be 2. So A is 2. B has to be 6. So 2 and 9 add up to 11. 6 and 5 add up to 11. That makes that 9. 6 eliminates 6 here, so it's 4 and 6 there. 4 eliminates 4 here, so that's 2, which eliminates 2 here. So it's 4, 9 as a pair. That's fine. This can't be 2 or 6. It's 4, 8. Here we have a 4, 8 pair in column 7, which limits 4 and 8 in the rest of the column. So this is a 6. This is 4, 6 here. 6 eliminates 6 here, so it's 4, which makes that 6. Okay, no 4 here because of 4 in the row. No 6 here because of 6 in the row. So we have 1, 6, 8 as a triplet in row 1 here. 9 eliminates 9 here, so that's a 4. That's even. So this cannot be even because we have 4 evens in the column. This can't be odd then because we have 5 odds in the box. So this is a 9, this is 8. That means this can't be 8, it's 4. This can't be 4, it's 9 and odd. Therefore, this is not odd here, it's even. So this is 9, that's 4. We need an 8 here somewhere. 8 cannot be here because of 8 in the column. So this is not even, that's odd, which means this can't be odd. That's even and is an 8. 4 eliminates 4 here, so that's 6. 6 eliminates 6 here, so that's 8. This can't be 8 here. 6 eliminates 6 here, so that's 1, which makes that 6. 1 eliminates 1 here, so that's 3, and it can't be 1, 3 here. It's 7, which makes that 1. That leaves this as a 3, so no 3 here. It's 1 and 5 as a pair. 4 eliminates 4 here, so that's 8. We don't have enough information about 1s. We don't have enough information about 2s. 3. In column 2, we have 8 3s. We know where the last 3 has to be. It has to be there. 4. We don't have enough information about. 5s, we don't. 6s. We have 8 6s. We know where the last 6 has to be. It has to be there. Oh, this is 2 and 9 adding up to 11. That eliminates 9 here, so it's 5, which makes the 7, which makes that 9. Sevens. We know where the 7 in column 2 has to be. It can't be here because of 7s in the boxes, so it must be there. We don't have enough 7s information about 7 here, though. 8. 1, 2, we have 8 8s. So we know where the last 8 has to be. It has to be there. 9s. We have 8 9s. We know where the last 9 has to be. It has to be there. So 1s, we're still kind of have not enough information. 2s, we don't have enough information. 3s are done. 4, we don't have enough information. 5. Well, 5 has to be here. So where's 5 in column 2? It has to be there, which makes this 7 and 5. Where's 5 in row 5? It has to be here. That gives us 8 5s, which means this is 1 5 there. Okay. 6s are done. 7s. We have 8 sevens now. We know where the last 7 is. It has to be there. 8s are done. 1, 2, 3, 4, 5, 6. Yep. 9s are done. So back to 1. We have 8 1s, so we know where the last 1 is. It's there. 2s. Well, 2 in column 9 can only be there, and the remaining, we have 8 2s now, so we know the last 2 has to be there, and the last digits are 4s. Very cool. Very interesting sort of rule set for the onions. I kind of like it, actually. It was interesting. But it required essentially the cages all summing to the same sum. So I'm not sure how extensible that is for the future puzzles. But it was definitely a very cool idea of just the onions having the same parity. Each onion layer that has cage cells having the same parity was really cool. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.